let us mute. Okay, welcome everyone. This is going to be the first in a series of tutorials on the basics of ROS2. In this tutorial, we're going to go over the basic concepts of ROS2, how it works, the overall architectural platform it's built on, things like that. And then at the end, we'll go over a little bit of how you guys can install it on your computer so that you can mess around with it at your house or during lecture. That's what I always do. That's the best time, etc. So let's begin. So before we get into ROS specifically, let's talk about some basic robotics. How do you interact with the world? Traditionally, we would interact with the world with hands, eyes, mouth, nose. All of these perceive the world, send that data to our brain. Our brain then takes that data, processes it, compares it to past data, and then using that, we can move our arms and legs. So, for example, I see that mouse on the table. My eyes get the light that coming off of it. It sees it's red and black and is shaped like a mouse. My brain recognizes that, and if I want to grab it, my brain sends the commands to my arms to go and pick it up. We can think of robots similarly. For example, we could have a program that would specifically take in data and then send that data to another program that would process that data in some way. Finally, that program would send it to another program that could then actuate, say, wheels or a pneumatic arm or something. So this is the basics of how ROS2 works. So ROS specifically is a set of tools and libraries for creating a distributed network of nodes. ROS itself stands for Robotic Operating System. Before anyone asks, it's not actually an operating system. It's just a set of tools and libraries for creating a distributed network of nodes that can each handle a small task that you would specifically program for. So for example, a node that'll take in LiDAR data, or a node that can communicate with a motor controller. These nodes can then each talk to each other through a publisher-subscriber style that I'll get into in a little bit. So as I mentioned before, nodes are just individual compartmentalized process that can send out data to any other nodes or receive data from any other nodes. And you can set them up with a singular or multiple tasks. As we can see in the bottom here, we have a little camera driver node that would then send an image to a node that's specific to finding an object, which would then send data to another node that would create a path to get to that object, which would then finally send that data to a motor driver node that would send the commands to the actual wheels that would then drive the robot. So as we can see, it's just a way to break up small tasks so you don't have just like one giant C file that you just run and it does the whole robot, and then something breaks like at line 5,832 and everything is pain. But with this, if one node breaks, it's usually only like maybe a couple hundred lines long at most, so much easier to debug. So as I mentioned earlier, nodes have a publishing and subscribing model. So the way this works, I personally like to think of it as a magazine style subscription. So for example, when you subscribe to like Forbes, for example, Forbes creates the magazine and then sends it out to you, but they also would send it out to all of their other subscribers. So like, whatever millions of people the Forbes magazine sends out to, this works in the same way. So you'd have one node that can publish a message, and then every other node that has subscribed to that node's topic, which is what I'll get into in a little bit, is what we refer to these pipelines where messages move through as, we'll be able to see that. So we can see here in the GIF below that one node is sending out a message, and then the two nodes that have subscribed to that topic are both getting access to the message. So this allows for a much easier way to create a network because we don't have to create a node publisher for every other node that wants to read the message. We just have one node publishing out data, and if I need like 2, 3, or 500 more nodes to be able to read that data, we can easily be able to read it. So moving on to more specific topics. Topics, as I mentioned, are just the transport system that allows for nodes to subscribe to and publish messages on. Each topic has to have a unique name. We traditionally namespace them with a slash, as we can see in the example there, where you would do slash namespace and then slash specific topic name. So for example, for our robot kiloohm, all our topics were slash kohm slash topic name, which just allows for easy the easy ability to distinguish certain topics from others. So you're all within the same namespace. As I mentioned, all messages that are published out on a specific topic can be seen by all subscribers to that topic, but if you only publish a message on a topic, you won't actually see any of the other messages on that topic. You would have to, if you wanted a node to publish and both subscribe to a topic, you can do that, but just note that if you're only publishing, you're not gonna get any data from the topic itself because you're only pushing out. This transport system traditionally allows for like one-to-many style or many-to-many, so it's just way easier. So the way that we send data back and forth is through messages. So messages is just data that's sent out over a topic. It's traditionally described with a .msg file. So if you look inside a ROS workspace, which we'll get into a little later on in this set of tutorials, you'll see .msg files that will describe different messages that will go out over different topics. And if you want to publish on a topic, you have to adhere to that specific rule set. So if you had, for example, a message type that consists of 2 integers, every piece of data you put out on that topic has to have 2 integers in it. So we can see, for example, in example message file, we have 2 int32s x and y for Cartesian coordinates, for example, and that would be a message. So any node that's subscribing to that topic would see that message and be able to, do whatever they want with it. Some nodes we have specifically for logging, some are for manipulating data. And yeah, messages can be made up of any primitive data structure as well. So ints, floats, you can do arrays. You can do as many of them as you want. It'll get more complex, of course, if you have like 47,000 floats. Some of the covariance matrices for things like LiDARs get rough. And of course, you can define custom messages for different applications. So a lot of sensors will have their ROS drivers will have custom defined messages that we have to then read and process. But it always comes back to just primitive data types. And yeah. So why use ROS? That's an important question when your whole club uses it. Well, ROS for us, it handles the communication layer, so it allows us to, as I said, easily spin up this network of nodes that can easily talk to each other and interact without us having to define that ourselves and set up that distributed networking system. It's used in industry quite a bit for prototyping. I know Toyota uses it for a fact. Ford uses it a little bit. Bosch does as well, so it's well used in industry. It's got a large amount of support and documentation. There's tons and tons of tutorials online to using ROS, and it's open source. So when it breaks, we can help fix it, or at least help put the problem out there so that someone else who's smarter than us can try and fix it. So that's traditionally why we use ROS. And before we continue, I'd like to get into a bit of a demo to sort of showcase what I've been blabbering on about this whole time. So if I go into, oh man, I should have kept these in my history. Oh well. No, it's not. But for example, we can see that I can do ROS2 run, and then this allows me to run a specific package on my system. So we're going to do the classic turtle sim package, which in ROS, a package is essentially just, it allows you to create a set of nodes that you can launch at any time. So for example, we can do turtle sim, and that'll bring up the turtle sim node, which as you can see here is a lovely little turtle on a blue background. So this node specifically spawns the window, spawns a randomly generated turtle, and just sort of handles where the turtle is in space. We can see that it says in the console spawning turtle at this X and Y position with a theta position of 0. And now if I go over here and I open a new tab in my window and I do ROS2 run and then turtle sim turtle underscore teleop key, this spawns another node that specifically takes in keyboard input. So now I can drive the turtle around and create little lines all over the place. So what's happening here is that we've spawned in the turtle sim node, which can look at potentially data coming off of the turtle sim teleop key node, and takes that message and moves the turtle around accordingly. So in order to view what's actually going on, we can open a third new tab. It's going to be a lot of new tabs with ROS, and we can do Rqt Graph. And if we run this and it doesn't die, it's just fine. It spawned anyway. Oh, computer is sad. Why is computer sad? Why do you make me sad? Oh my god, my graphics card is melting.
Yeah, this is definitely OBS.
Thank you, OBS. Love you too. We can see that Rqt Graph allows us to bring up a graph of all the nodes and topics in our system. So we can see that we have the teleop turtle node, which is the one taking our keyboard input. And then we can see the turtle sim, which is actually displaying the output, which is currently a black box. There it goes. Cool. Which is currently displaying the output. And then we can also see that these arrows are each individual topics. So we have turtle1 command velocity, which is the command velocity that the keyboard input node teleop turtle is getting. And it's sending to turtle sim, which is reading that and then moving the turtle around. And then turtle sim will also send back our absolute rotation and our absolute status as actions, which is a later problem. So another unique way to view this is through the command line. And this is just a quick overview of a few of the ROS2 command line tools. There's a bunch. But if I do ROS2 topic list, we can get a text list of all the topics on the system. So we can see that we have the ROS out, which just allows for printing to the console. Turtle1 command velocity, which is, as I mentioned, is what's sending to the turtle sim in order to run it. The turtle1 color sensor, which is unused here. And then the turtle1 pose, which is where the turtle currently is on the screen. So by using this, we can visualize easily if all the topics are being published on, because topics that aren't published on will not appear in this list. And if we go ahead and do ROS2 topic echo, and then we enter one of the topics from our list, that is, help. There we go, turtle1, and then if we did command velocity, there we go. We can see that now, if I jump back to the command velocity and give it some more movement commands, we can see that over here, we start being able to read all the data that's being published out on a topic. So I'll dump this out. Oh my god, OBS is crying. OBS is so sad. So in order to better view, we can see that as I hit the buttons on the keyboard to move the turtle around, we can see that the data is being fed into the console on the left. So this easily allows us to be able to visualize what data is on a topic. So for example, if we have data that is being weird, or we need to quickly see what something is doing, we can just easily throw this command up and it'll start displaying all the data that's being displayed, and we can begin to debug if something is going wrong somewhere. So that's a couple of the command line tools that we use, as well as a quick demo of sort of just to show more of what I'm talking about. So finally, I know I've talked about ROS2 is what we use specifically, but there is a ROS1 which was created a little while before ROS2, of course, and going from ROS1 to ROS2 is just a switch from a custom middleware solution to something more common. I mean, it's just going from TCP ROS to the more standard DDS middleware. You can look that up if you're more interested. It's just a better implementation than ROS1 because it's not something they're writing themselves, which is nice. However, the disadvantage is that going from ROS1 to ROS2 is a complete rewrite. So we were using ROS1 a couple years ago, and the movement to ROS2 required us to completely rewrite our code. So in case you're curious as to why we use ROS2 specifically, that is why. And finally, the best part, installation. So the main idea that I have for this meeting is less instruction and more of getting everyone set up with Linux. So ROS technically runs on Windows. It is supported. However, I would highly recommend installing Linux in some capacity. We currently use ROS2 Galactic, which requires Ubuntu 2004 specifically. If you install 2204, it will not. You can install Galactic. You may be able to compile from source, but you can use different flavors of Ubuntu if you want. So Kubuntu is pretty nice. I know Andy personally uses it. I've used it a bunch on this machine, and it's pretty good. I mean, either one, as long as it's a flavor of Ubuntu and it's 2004, that's fine. And there's a couple different ways to install if you want. So you can either do a virtual machine through like VirtualBox, you can dual boot, or you can just send it and install it on your main drive and just go for it. Obviously, a VM's not going to be very intrusive and is easily reversible, whereas your primary OS, it burns everything. So, yeah. So from here on out, we're going to sort of I'll go through a little bit of using VirtualBox. So if you want to get set up with VirtualBox, because it's sort of what I'm going to be targeting, as it's easiest to set up now. Normally, like dual booting would take significantly more time, but if that's what you want to do, send it. If it would load, there it goes. Cool. So obviously go to VirtualBox's website, download the VirtualBox 6.1. It should take you to a downloads page that shows the different OSs. If you have Windows, download Windows. So then let me pause here, because I assume that most of you don't have VirtualBox installed. If you do, fantastic. If you don't, that's cool as well. Side note, some of you may have to enable virtualization on your systems through the BIOS. If VirtualBox dies when you try and boot the VM, that is probably why. I think it warns you on install. Yeah, it'll warn you on install. And if that's the case, you have to go into your computer's BIOS and enable virtualization. But once you install VirtualBox, you should get a screen that looks similar to this. So, yeah, I think we're going to pause here. Yeah. Yes. At least, I really hope so. I don't see why it wouldn't. Windows 11 is just Windows 10, but we rounded all the corners out. Well, yeah. If it doesn't support Windows 11, I'm gonna be.
That page says it runs on OS2, so I'm guessing those.
I would love to run VirtualBox on OS2. Hell yeah. Cool beans. Yeah, this is what I expected. This is what I've somewhat. The other thing that I'm going to need, actually, you guys should probably start doing this now. I did just think of this. You have to get the ISO for Ubuntu 2004, and it's 3 gigabytes, and man, the school's Wi-Fi was not built for that. So
It's more that it's meant to be torrented, but torrenting on the school Wi-Fi also makes U of M not happy.
it's fun facts.
It's a very slow download.
Yeah, sadly. So go to ubuntu.com. You'll go to download, and it's buried. It's actually really annoying to get to now. Yeah. But if you're on ubuntu.com, you can go to Ubuntu Desktop, and then alternative downloads. Bada bam. Not BitTorrent. Where did she go? There it is. Past releases. So it's going to be focal fossa. Ubuntu 2004 LTS. Numbers are easier. So I'm sure if you Google Ubuntu 20.04 download, it should come up with this page. But that's just how to get to it from the main Ubuntu website. So I would recommend pulling that down because it's 3 gigs and makes me sad every time. If you already have it, great. So if anyone has any questions as well, feel free. Yeah, so now scroll down a little. So past releases under flavors. So Ubuntu 2004. Oh no, you could. I mean, it's fine. Scroll up. Yeah. That one. But it's just the desktop, just a 64-bit desktop image. And that should start zooming in. Yeah, the 64-bit desktop image is the one you want. And then that'll start. Then we can get into. And again, if you plan on like dual booting or sending it, you don't have to set up Virtualbox and everything. This is just Virtualbox is easiest. So. Yeah, if you dual boot, cool. Virtualbox works great as well. Works fine enough. Either one is fine. So, whatever you're comfortable with doing. So I know that dual booting's, yeah, some people are less comfortable with that. So Virtualbox is easiest because if you don't want it, you just uninstall everything and then it's gone. Glory of virtual machines. So. Should probably end the OBS.
If you don't want to keep it circulating, that's up to you. How much drive storage do you have?
136 gigs. If this is 136 gigs of combined video, I'm gonna cry.
Dying is I kind of forgot to change it off of CPU encoding. So it's CPU encoding and also driving 2 4K displays.
Honestly, she's a champion right now for handling this.
It's honestly kind of impressive.
The fact that she hasn't forced shut herself down is. She does good work. She's very warm. Cool, so let me know once you guys have the. Sorry? Oh, are you just creating the virtual machine right now? Cool. Yeah, so you're just going to want to go to new. We're going to name it Linux. Bam. Go to next. You're going to want to give it some RAM. I recommend, depends on how much RAM's in your system. I recommend at least 4 gigs for stability. Go to next. Create the virtual hard disk now. You're going to want to do just the VirtualBox disk image will be fine. Go ahead and go to next. Make sure it's dynamically allocated. Do not fix size. I'll make it sad. Dynamically allocated just means that as you use space in your VM, it takes up more space on your drive. If you statically or like fixed size allocate it, when you on the next tab over here, if you set it to 8 gigs and you set it to fixed size allocation, it's just going to take up 8 gigs immediately. Dynamically allows it to slowly expand, so it's not as bad on your system until you start installing a lot of stuff. I'd recommend not 2 terabytes. I'd be impressed if you could allocate 2 terabytes of this. I'd recommend probably at least 20 gigs for Ubuntu and everything. If you have less, you could get away with like 15 or 10. But once you go below that, because ROS2 itself, installing the framework takes space, so we would just go to, I'm just going to do 16 for giggles, and we're going to go to create. And then what you're going to want to do is you're going to want to go to the 3 dots. Is it 3 dots? Oh, God. Oh, no. It was settings. My bad. Settings. And then you're going to want to go down to storage and settings, and then under the controller IDE, under empty, you're going to want to click the CD button to load in the ISO. So just go to choose a disk file here. And then if I can find my file, because I downloaded this earlier, here's like Ubuntu. Bam. So you're going to want to find the Ubuntu 20.04 ISO, hit open, and then hit OK. So now let's load it in. And then, oh my God, I'm going to try and start a virtual machine on this thing. She may actually die doing this, but you're going to want to hit start, and then it's going to boot the virtual machine and hopefully be less sad. There it goes. There it goes. It's going to be small because this is 4K, and I think this is running at 600 by 400 by default. So it's going to... you can sort of see it on that one. That's so you're going to want to click... are you in the main VirtualBox screen? Yeah, so click New. Yeah, so click New. Yeah. And then, yeah, it'll bring up that menu. So you'll be able to... Yeah. Just, yeah, create hard disk now.
And does it only pick up 4 gigs of RAM?
When it's running, yes. So when it's off, it's not going to do anything to your system. So you'll just chill in the background. And then come on, Ubuntu. Just the default. So virtual, yeah. And then, yeah, how much space you want to dedicate to it depends on, of course, how much space you have on your system, and how much you personally want to do. Yeah, later on. You can resize it later on. So then it's gonna boot. It's gonna boot a little slow because I think my CPU is probably pinned at 100% right now. And it'll bring up the install page. Just VDI VirtualBox disk image. Yeah, so just default. And then, yep. Yep, decide how much you want to do. No, you're good. Listen, she's over here singing the song of her people, so you know, it's all good. But yeah, if anyone needs help or has any questions, yeah. So, in general, though, once you do get to here, you want to just go to install Ubuntu. Wait, because again, it's English US, of course, unless you don't want English US for your keyboard and language. And then then yeah, how much did you give it? Oh yeah, I don't remember what the Ubuntu's minimum is. Yeah, I would try and give her a little more. You should be able to adjust that in the settings of the virtual machine. If you go to settings and then storage. But yeah, so just continue through the install prompts. So normal installation, download updates while installing. And then, wait, because it's saved. Probably like 4 gigs will be serviceable. You can adjust it later, of course, if you start running into issues with RAM. Everything's adjustable. Number of cores that it takes, RAM, storage, and then. Here. Oh yeah, well you'll have to. Is it? Yeah, you have to. Just because when you restart it, it'll bring up the install script again because it's just running off of the live ISO. Or you can just port that off the machine. Oh no, you don't have to uninstall Virtualbox. Just go ahead and because Virtualbox allows you to create multiple VMs. It's just oh no, so reopen Virtualbox, just the program itself. Yeah, and then you can just so you just click and try again. So that's what's really nice about virtual machines, which is why it's generally recommended, is because if you blow up Linux, for example, Like if you blow up Linux, for example, which does happen from time to time, you can just delete it and it's chilling. You can make backups of virtual machines. So
presumably him? I don't really know. It doesn't look that bad. But 90% is just chaos. So like, our machine can just be for search transfers with building interactions with the debugging. What we're changing is the building guys. Like if you look through a lot of like this pre-processing Python is just straight taking screen grabs and then putting them in OpenCV. Like it's nothing we haven't already done. Like this is exactly what we does with us. It's just adding random twists and flashes. You know, it's trying not to overtrain it. Yeah, that kind of stuff. Because he's using a sim. So yeah, so work with it such exactly. It's actually identifying features and not just biased. Yeah, and then a lot of the rest of it's either very specific ROS stuff or just general stuff. The biggest thing is just interacting with sim, which is running the inference, running the sim. But we need to make that physically too. These don't make it physically. So we need a ROS node that does that both for sim and IRL. So for IRL, we just need to load the message flow model and then send it via and then get it back, and then just send it as a message to hardware. Yeah. That's gonna be cool stuff. That's gonna be actually really cool. I can help this as well.
So I would,
Yeah. That's
now, VirtualBox virtual machines by default will only run on one core of your computer. I would recommend changing that in settings, which is just under, oh please, oh Christ, under settings and under system, you can go to processor and change the how many CPUs it uses, and it's based off of the amount of cores on your machine. So for example, I have a 12-core CPU in here, so I can choose between 1 and 12 cores. They give you a little red bar that, if you go into the red on this slider, that just means that your host system, so your Windows system's performance will start being hampered if you give your virtual machine too many cores. So sort of the trade-off there. But more cores you give it, the speed go up, generally. So that's what I recommend. But I believe you have to install before that's available.
Yeah, you can figure that before you turn on the virtual machine.
Yeah.
So for installing,
Yeah, because it just sees your virtual hard disk and is like, oh, this is free real estate. Send it. And it'll ask you for some, you can see it's asking me for my name, my computer's name. I'm gonna do J. Yeah, that's fine. I'm gonna do J, and I'm gonna choose my super strong password of A, and then A. And then I think Ubuntu actually Ubuntu doesn't care, which is, yeah, you can have no password. You can have,
No password auto sign on.
yeah. So you don't have to have a password. It's a virtual machine, so if you get a virus on it, just delete it. It's chilling. It's all good.
I would give you the password though, because if you don't, when it prompts to root, I honestly
experiment, have fun. That's what we want. That's what we want to do here. Blow up Linux installations. That's RMRF slash. It's like slash. I think you have to do don't keep root or no keep. There's like another. They added more checks because they can never add enough checks to keep you from uninstalling your whole OS. But yeah. So. Yeah, as we can see, it's doing the thing. Yep, so just erase disk and install Ubuntu. Just install now, and then it's going to ask you for your user information. As I mentioned, you can do whatever you want. Virtual machine don't care. So, and then once this is set up, we'll go through getting ROS installed and getting TurtleSim to run on your guys' installations, so you too can drive the turtle around and experiment. Sorry?
What does it mean by TurtleSim?
The TurtleSim is just the demo, like a demo node that they include with ROS when you install it that allows you to sort of get a feel for how the work with it through the command line. It just pops up with a little. It's a oh I closed the oh, I'm an idiot. I closed the tab. I'm so sad. Do I have it in my yes. So if it's just TurtleSim node. Oh my god, please. And then it just spawns this window. And then you could spawn another node that allows you to drive around. So that's all the TurtleSim is.
Is it kind of library?
I'm sorry?
Is it kind of library?
Yeah, so ROS itself is a library. The TurtleSim that I just showed you is just one node that's running that displays a window and then the little randomly generated turtle inside of it. But ROS itself is a library of tools that allows you to create things like that, or other nodes that you can use to create, motor drivers, drivers for lidars, things like that. So come on, Ubuntu. I know. Solid. That's so custom. That's cool. Did it say specifically observe it? Yes. Nice. Wow. Yeah, it takes a... So who here is waiting for it to install? Cool.
You can carry on. I'm not
Oh no, I'm also waiting for it to install. I probably should have made a full one, but if you want to get started, yeah, it's bright. If you want to get started with actually getting ROS installed, if you just look up ROS2, why is my cap lock on? Installation. If you look up ROS2 install, and you just go to, it should be like the first or second link. The page should look like this. Make sure that you're looking at Galactic, because that's the version we use and the version that's actually going to run on 2004. And then you're just going to want to click on, under Ubuntu Linux, just click on Debian packages, and then essentially you're just going to want to follow these steps. So these just ensure that you have a locale set up. They set up the sources and make sure you have the ROS repositories on your system. Install a few required tools you'll need, and then actually just, installing the package. So it should just be one command to install all the ROS tools and fun shenanigans. So yeah. Wow, look at her go. What was that? Do you need help? Okay, yeah, that's no problem. I mean, video will be up, so if you want to go back and look, it's gonna be a surprisingly large amount of dead space. I mean, not surprising. Yeah. Hell yeah. We'll see if the ASMR mic picks you up, but yeah.
Actually, no, this is a recording mic. It's singing or whatnot.
Hell yeah. I hope not. I don't think anyone here wants to listen to me sing.
That's for IC.
Hell yeah. Are we doing karaoke for IC Game Night? That is required at this point. Stick around for ISC Game at some point. Game Night at some point. Well, yeah, I have nothing to say to that. That's just true. That's just true. I was gonna say COVID, but I realized that wasn't COVID year. Well, yeah, but we were at least like in the lab space. I don't think. Oh no, they weren't letting us do like. I don't think they were letting us do like. Yeah. See, not our fault. Not our fault. It is a winter kind of thing, but yeah, not our fault. That's what we like to do here. Shift responsibility. To the school specifically, yes. Yes. Listen, I pay them X thousands of dollars every semester to go here. The least they can do is just take some blame for me. Come on, DBKG. Help me out. Also, I know it should probably unnecessary to say, but please change your screen resolution in the VM to be your actual screen. Don't live with this. This is pain. No, Ubuntu comes with it. It's just, you just go into settings, and you go into settings and then under your display, if you haven't done it. Another quick question I just wanted to throw out there. How many of you are familiar with the Linux command line at all? Got a little? You don't count, and you don't count. And it's huh? Yeah.
You transfer them really easy.
Yeah.
You just change the names, like DIR becomes LMOS. Clear. CLS just becomes clear. Same concept.
Yeah. So okay.
I'm dual booting, but I haven't actually used Windows this year yet, so I might.
I also haven't heard
Yeah.
your computer get sent to space during class, so like.
Okay. So you're using it as your primary host. Okay.
He's
Yeah.
filming me is what we're doing.
Yes. Okay. So, any questions? Just, man, she is suffering right now doing this. I'm asking a lot of this laptop, running the OakD,
Hey, if
recording,
you would hit
driving. I think this is driving it. Is this driving it?
here, go to the cases.
No.
Go to cases. Something.
Oh, God. Oh, my monitor.
Yeah, go to cases.
Oh, that's not terrible.
That's okay. The CPU is sending it, but the RAM is actually okay.
Oh no, I wasn't worried about the RAM usage. I was worried about all my cores like flying all over the
I think
place.
that's a lot, but it's not the worst I've seen. It's pretty impressive for encoding a 4K.
That's true. No, I've had those sick CMake compiles where it's just 100%. No, Culkin does the same thing. He'll just put everything to 100% and then drop it. Compiling ROS was rough.
Where do you change the core from?
You do it in the settings of the virtual machine.
Yeah.
That would be there. Let's see. This is like the virtual machine first.
I can't see this through my dongle, but I programmed Josh's through the dongle.
Nice.
What are you doing?
Well, looking at the stream.
Oh my god, the camera.
I want to see what I can't see the Actually, I can. Oh no, I can pull up the demo. There we go. Oh no, I can't. Yeah. Yeah, I want to see what the camera was seeing.
Yeah.
Um,
It's not
oh, cool.
designed for this use case.
No, not at all. But is it being used for the use case? Yes.
Should have got the one with structured light. Just have it be like the
I need the streamer ring light. That's what I need. I gotta get the whole. Yeah, I gotta get that. Get the Elgato Stream Deck.
I have a stream deck.
I need the Elgato Stream Deck, the Stream Light. Bro, I'm gonna get so many followers on Twitch.
I kind of want a stream light actually. It's just a really convenient light cover. This is a beauty dish is what it is. They're not hard to DIY. We should DIY.
Honestly, I'm down. I should pop on through it. Oh my god, this thing is so sad. Yeah. Probably should turn.
Remember people told me the grab ball was in the charger. I think that's why it was in the charger. It's power only.
I don't know, I pulled it out of the micro B box randomly, so it could totally be.
It just isn't fully not connected.
This is why micro B is objectively like one of the worst connectors.
It is. It's just. And this has a USB-C cable on it. I just can't get it.
The only one that's worse is the that weird flat B. That flat USB that
Well, that's just micro. That's just mega B.
Yeah, it's bad B is what it is. Can Ubuntu please boot?
Quick question.
Yo,
What happens if you use all of your cores on Linux?
I believe it time splices or whatever it's called.
it
It's
makes
a
it makes Windows sad.
It,
I mean, you totally can. Don't get me wrong.
Yeah, you totally can. I mean, the classic thing if you're running a heavy VM is you give all cores to all
Oh,
one
it was A.
core to the guest, and then give integrated graphics to the host and
What?
dedicated graphics card to the guest, and then you're
What is
basically
it,
just running
Capbox?
a separate computer. That's more of a workstation setup though. A laptop.
Scapula.
Just kind of send it.
Yeah.
Hardware really isn't built for this.
Yeah, I would just whatever's in the. I mean, if you give it, depending on how many cores you have, if you can spare like 4, that's fine. That's fantastic. You'll be rock and rolling. So.
I mean, honestly, I normally just give all my cores and just kind of accept whatever happens, and that's worked. So. I'm searching with the reviews.
I believe in you. Oh my god. Where's my... There it goes. Fantastic. Wow, 1920 by 10 is still very small. Yup. Just skip. Oh, and of course, make sure you don't upgrade now. It's going to prompt you to upgrade to 2204. Don't, of course. Just want to make sure, more for the video, for the recording. So, yeah. Wow, I should definitely give this thing way more cores. Oh. Yeah. So, as I mentioned, you'll go here, and then just running through the installation.
Is there a way to like copy the commands and paste them?
Yeah, so there should be a little, if you hover over for commands that are only one line, because if you do this for multi-line commands, they'll just copy the whole thing. But for like one-line commands, you can just hit copy to clipboard, and then to copy in the terminal is Control-Shift-V. You have to do Control-Shift-V and Control-Shift-C to copy and paste from the terminal on Linux. Otherwise, it will not work. So if you're done with running through the installation steps and you've run sudo apt install ROS Galactic Desktop, if you want to test your Linux installation, you can just go into here and then run ROS2 run turtlesim node, and that should bring up the adorable little turtlesim guy. So yeah. Yeah, so the arrow keys will move the little guy around in the oh god, no, stop. Everything's bad. Yeah, the arrow keys will move him around if I file tab. Caps locks. Yeah. Turtles. Yes, it's just. Yeah. Cool.
I found a 404 on the IC website.
Solid.
I'm not sure if I got this right. I assume I haven't.
Did you do the commands to add the because you have to do the set up the sources commands. Did you do those on the? Yeah, so you have to make sure you do those as well, because you have to add the ROS2 repository to your list of repositories your computer's going to look for updates. So, but yeah. Is everyone... But yeah, so we would just... So after you install, if everything's gone well, you can go and run, make sure you source the setup script. It should say that underneath environment setup right here. So you have to run this inside of every new terminal that you open, or what you can do is what I would recommend is to add it to your bash RC. So to do that, you would just go to here. After you've installed, you would do nano and then dot bash rc like this, and that'll open up a command line text editor that you can use, and then I would just copy paste the source /opt/ raw/galactic/setup.bash and just paste that at the bottom of the file. So just scroll all the way down to the very bottom and then just Control Shift V, and then to save that you would just do Control O. and then it'll say file name to write.bashrc. You'll hit enter, and then it'll say wrote X lines, and then when you're done, just hit Control X, and that takes you back to the terminal. And that way, every time you open a new terminal, that command will automatically be run, so you don't have to do that for every single terminal you make. Cool. So, yeah. I'm going to cut. Man, I should turn the light on. Oh well. I'm going to cut the stream here.